Hello everyone, I'll take you through a brief introduction to temperature sensors and transducers. The learning outcomes are, by the end of the session, you should be able to define what is a sensor and what is a transducer. You should also be able to describe the various examples of temperature sensors and transducers. So we start with the definitions. A sensor can be defined as a device that gives an output by detecting the changes in quantities of a variable. Hence, in our case, a temperature sensor detects changes in temperatures and gives a relative output. Transducer is a device that converts energy from one form to another. A temperature transducer hence converts a temperature change into a physical variable, e.g. into an electrical signal, which can then be processed to give the value of the temperature change. So what do we deduce from the definitions? Sensors can be transducers. However, a system may use transducers in addition to the sensors to convert signals from one form to another. Examples of temperature sensors and transducers. One, we have bimetallic strip, liquid in glass thermometer, thermistors, thermocouples, thermodiodes. We shall look at each of these examples and describe them further. So, bimetallic strip. A bimetallic strip consists of two different metal strips of the same length bonded together. Because the metals have different coefficient of expansion, when temperature increases, the composite strip bends into a curved strip. Here we have an illustration of the same. So when it is heated, the higher coefficient metal that is on top will expand faster and it will pull the whole strip upwards, making or opening this contact there. Liquid in glass thermometer. This is very common in our laboratories. It consists of a capillary tube and a bulb. So the height to which the liquid expands is the measure of the temperature. The common liquids used are mercury and alcohol. Thermistors. Thermistors are semiconductor temperature sensors made from mixtures of metal oxides such as those of chromium, cobalt, iron, manganese, and nickel. The resistance of thermistors decreases or increases in a very nonlinear manner with an increase in temperature, and that is for negative temperature coefficient or NTC thermistors. The resistance decreases with increase in temperature, while for positive temperature coefficient thermistors, it increases with the increase in temperature. That is how the devices look in a circuit. Thermocouples. A thermocouple involves two junctions formed by joining two different metals together. Thermocouples operate on the physical principle that when any two different metals are joined together, an EMF, which is a function of the temperature, is generated at the junction between the metals. So this is what we are calling the hot junction that is in contact with the body you are measuring the temperature. This is now the reference point. Now the EMF here, it's although small, but it can be processed now further to give the value of the temperature of the body we are measuring. Thermodiodes. These operate on the principle of PN junction, whereby voltage across the diode changes linearly according to the temperature changes, i.e., as the temperature increases, diodes forward voltage decreases. Thermodiodes are normally embedded on microprocessors to monitor their temperature and also in temperature sensor integrated circuits, e.g. LM3911 and LM35. That is how the ICs look like. For your assignment, you should be able now to categorize the examples learned and state for each whether it is a sensor or a transducer. Research on the applications of the various temperature sensors and transducers you have learned in this session. Goodbye.